Alright, in this video, we are going to take a look at how we can go about implementing the MMO peer class. So the peer is it's a component that plugs into Photon, and there's one peer per connection. So our peer is kind of our abstraction over a single connection. Now we've really already sort of abstracted away the concept of a peer by working with our contexts. And our contexts are nice, our client context and our player context, because then we can give specific behavior to a client that connects as a player or any other sort of thing, like I said earlier, like a dashboard or a region server or any other thing that we might want to express. Of course, for now, we're only going to have a player context. But we have to have the peer implemented so that it plugs into Photon and it knows which context to instantiate, and it then defers things like the on operation request and on disconnect to being handled by the context classes themselves. So the way that I want to go ahead and do this is I want to have a sort of handshake operation happen when a peer connects. So there'll be an operation that the client will send upon connecting, telling the server what kind of connection it should be, whether it be a player or a dashboard or something like that. Now, in the case of a client connecting in as a more privileged context type, such as an admin panel or a dashboard, we would need some additional authentication, which we would handle here during that initial request. But for the player, we'll just go ahead and pretty much let anybody authenticate as a player, because they're going to have to go through the login system anyway to send the player credentials. So what that's going to necessitate us doing is we will have to go ahead and put in an operation code, a new operation code, which we should have that enum here in our infrastructure namespace. Yeah, we have our operation code and our operation parameter. So our operation code, remember that for the most part, the operation code is going to be mostly ignored. Remember, the operation code is what is sent in through this operation request so that we know what the client is wanting to do with the server. But for the most part, we are going to just be deferring that to the concept of the system. So, for example, if there's a system of ID 1, the operation code would be 1. But that would only be valid once we know what kind of context we need to instantiate so that we can defer the processing of that to the proper context. So before we have a context instantiated, we need some sort of handshake procedure, which is why I'm going to go ahead and I'm going to put in an actual enumeration item here in the operation code for denoting that. So I'm going to go ahead and in this enum, which you can find in the infrastructure namespace, I actually don't know what to call this, like init request or init context or something like that. I don't know, but init context, sure. So this will just be the first operation that any client sends. We're also going to have to add a new operation parameter. So I'm going to go into the operation parameter enum, and the operation parameter that I'm going to add is what kind of context that we're wanting to initialize. In this case, like a player or dashboard admin, whatever. So I'm going to add a new member here, and I'll just call this context type so that we know what the client is attempting to authenticate as. Of course, we will also need an enum to represent any of the context types that we may not want to initialize the connection as. In this case, we'll only have a player type, but that's okay. Let's go ahead and create that enum. I'm going to go in the infrastructure namespace, and I'm going to create a context type enum, sure. And so the context type enum is going to go ahead and have a backing type of a byte, because I highly doubt we'll have more than 255 different context types. And I'm only going to put in a single member here called player. So again, at first, the system will only allow player context types, but that's fine. We can add to this enum to represent different context types in the future. So now coming over to the peer, what we're going to need to do is, so we have our init request. The peer itself is going to be responsible for instantiating our different specific context types. So if you, for example, look at the player context, you'll see that the player context requires passing in an application server context as well as an iServer transport. These are the two kind of main sort of global objects that we need to have access to in order to perform any of the operations that we've implemented so far with the system. So that means that the peer itself is going to have a reference to the application. And it's also going to need to be able to supply a server transport. But fortunately, supplying a server transport is going to be easy because the peer itself is going to implement that interface. So for the constructor, let's go ahead and just start off with the constructor. You notice that we do take in an init request and we pass it off into the base constructor. And that's not going to change because that's a implementation detail of Photon itself. So we're going to always need that init request. But in addition, I also will require that we pass in a server context as well. So I'm going to say server context application. Now, as far as the actual implementation of the constructor, really the only thing we need to do is I'm going to remove this throw new not implemented exception, and I'm going to go ahead and store a reference to the application that was passed in through the constructor by assigning it to a private read-only field. Next up, I guess since we're already near the top of the file, there's two more changes that we're going to need to make up here. One of them is like I said, the peer itself is going to implement the iServer transport. So we can have that happen up here at the top of the class, and I'm just going to make it implement iServer transport. And I'm also going to go ahead and implement the members. So we have send data, send system response, and another send system response. And I'm going to hit enter. And so now you see that we have these three methods implemented. Now you might be wondering, if you've been paying very close attention, the server transport doesn't just have these three methods that you see implemented here. You'll notice that the server transport that I'm implementing here in the MMO peer, we're only implementing the send data, send system response, and the second send system response overloads. We're not implementing the disconnect overload, or the disconnect method, sorry. And that's because the disconnect method is actually a part of the peer base itself, and we're getting an implicit implementation of disconnect. So the disconnect method in this interface is being wired to the disconnect method in the peer base itself. I can show that to you by decompiling peer base and hitting that and going down to disconnect. So you see disconnect is a part of the base class, so that'll be wired up with the interface, which is exactly the base or the behavior that I'm looking for. So I'm not going to worry about implementing disconnect explicitly. We can do that if we wanted to. There is a little bit of syntax in C# we could do to explicitly implement this disconnect method and not have it implicitly taken care of by the base, but we won't need that for right now. Okay, now that we've implemented server transport, I mean, we've gotten the methods there, we haven't written anything in them yet. Let's go ahead and add one more thing to the top of the file, or the top of the class, which we'll need. We'll need a reference to a client context. So I'm going to say private client context, and I'm going to call this _ client context. Now you notice a couple interesting things about this field. First of all, we are not initializing this field in the constructor. Second, it is not read-only. It's not read-only because we don't know which client context to instantiate yet, and if you recall, the read-only modifier on a field prevents that field from being assigned to anywhere other than the constructor. So by putting a not read-only, it'll allow us to assign this to something later down the road once we have more information about what the client wants to do when the client connects. So let's go ahead and do onOperationRequest. This should be a pretty straightforward method. It really only has two cases. Either A, the client context is null and we don't know what the client has authenticated as, or B, the client context has been instantiated and then we defer the onOperationRequest into the client context. So what I'm going to do is I'm going to say if client context equals null. And if client context equals null, what we're going to do is we're going to extract out the operation code. So I'm going to say var operation code equals cast to operation code operationRequest.code. And so again, the operation request object contains all the information about the request and adds this handy little operation code that we're going to cast into our own operation code. Then I'm just going to make things really simple here because we only have one operation code that we even want to deal with. So what I'm going to do is I'm going to say if operation code does not equal init context, then throw new, I guess, argument exception. Sure. Operation code blank, which is operation code, is not supported. Okay, so by the time we get to this point in the logic, we know that we did have an init request or an init context request. So now what we have to do is extract what kind of context we want to initialize. So I'm going to say var context type equals cast to context type, then pass an operation request parameters, and then I'm going to cast to byte operation parameter dot context type. And I'm going to go ahead and if the client doesn't provide this parameter, I'm going to go ahead and have it throw an exception because that's fine. If the context type was not provided as a parameter, we'll get an exception right here, but that's perfectly acceptable because in that case it's an invalid request anyway, and I want to halt execution of this request entirely. Then what I'm going to do is I'm going to say if context type equals player, do something else, throw new argument exception. Context type blank is not valid, and we'll pass in context type. So I'm just kind of putting the else there. I guess instead of, I could have just inverted this if right here to remove some levels of indentation by saying if context type does not equal player, throw exception, because we don't have any other context types between player, and if they're not authenticating as a player, then, well, we don't support it because we only support players right now. But I'm sort of preemptively putting up a if, else if, else if, else if, else sort of structure here, which I don't imagine to grow very large. I only imagine we'll have a handful of these context types, maybe up to 3 different kinds. So I'm going to leave the code here inside of this method. To clean this up a little bit, we could quite easily extract this into its own method, and if it ever becomes too complex, we can go ahead and do that. But for now, the logic is so simple and straightforward that leaving it all in a single method seems to be an appropriate choice. So if we try to initialize ourselves as a player, we're pretty much done because, like I said earlier, there's no additional authentication that we have to do with players. Anybody can be a player because the authentication is handled by the login system. Whereas if it was like an API or a dashboard, we might want to do some sort of key authentication here to ensure that it's not a malicious connection. But in this case, we know we are initializing a player, so we now know that we must go ahead and instantiate a client context, and we instantiate it as a player context, which you'll notice is the only choice that we get from ReSharper from the autocomplete. And the reason that is because client context itself is an abstract class, and the only implementation of that class we have is player context. So we'll instantiate that, and it's going to want us to pass in the application and the server transport. Well, we have both of those bits. We have underscore application, which is the field we got from the constructor, and we also have a server transport, which is ourselves. So we're going to pass in this. That's actually all we need to do in this case. All we need to do is instantiate this, because if you recall, when we instantiate a player context, the constructor is going to send the player init event to the player connection, which contains all the information a player needs to know. I don't really know if I'm a huge fan of the way I put the server context class together, but since it's a relatively small class, I'm not going to worry about it right now, but just a heads up, I'm thinking about refactoring out particularly the player systems component map, and the actors, and probably the player init event. I don't really like these bits of data being inside of a global object like this, but they don't really have anywhere else to go, so I kind of tacked them onto this class because this class is so small anyway, but just bear in mind that I might be changing that later. Either way, once we've back into our MMO peer class, once we've instantiated the player context, we're fine, because the player context will go ahead and send the data to the player, telling him about all the systems and all that fun stuff, and everything is awesome. So at this point, we might want to add a new system, like actually instantiate a system here, which I haven't figured out. I actually kind of glossed over that, because what needs to happen is we need to instantiate the player context, then we need to put in an initial system, like a login system or something like that. I'll figure out a way to do that later. But for now, we can go ahead and complete the MMO peer, because other than that, this class just needs to be written once. It's pretty straightforward. So we're going to say if client context is null, do all this stuff. Otherwise, all we need to do is say client context.onOperationRequest, and we need to pass in an operation code. So I'm going to cast operation code. Actually, since we need this operation code anyway, and we've already extracted it from this branch of the if statement, I think what I'm going to do is I'm going to take this variable that we have right here, this var operation code equals cast operation code, and I'm just going to dump it outside of the condition. Because we kind of need it with both branches. We need it for this branch to know if we have an init context request, and we need it in our on operation request branch as well. So coming down to this else statement, I'm going to pass in our operation code, and then I'm going to pass in operation request dot parameters. And that's it. So hopefully you guys see how thin this whole system is. I mean, we have an on operation request. Assuming that we've initialized ourselves, we go into the context on operation request, we go into the invoke method on system, it extracts some information about the request, and then it invokes the method directly. So it's a very, very thin sort of RPC system that doesn't rely on any reflection, really, after the initialization period. So hopefully, hopefully that's all good stuff. All right, so now we have on disconnect. So the first thing I want to do is, that's annoying. All I did there was remove the namespace qualifier and to import the Photon host runtime interfaces namespace. I really don't like seeing namespace qualifiers. It just irritates me. So we have on disconnect. So what does that do? Well, on disconnect, all he's going to do is say client context dot on disconnect. Because you recall, on disconnect is this internal method that will actually perform the disposing of everything. So the reason why we kind of have this circular thing going on here is I want the peer, if the peer disconnects, I need the client context to dispose. Or if a person tells the client context to dispose, I need the peer to disconnect. And then once the peer does eventually disconnect, I need the systems and the client scope to be disposed. So we kind of have this circular thing going on, but we hide the circular nature of these two classes by marking on disconnect as an internal method, meaning that no method outside of this assembly will have access to it. So I actually would prefer if it was if .NET handled this like C++ handled this with friend classes, but unfortunately internal is the best we have in C#. So that's on disconnect. Not a whole lot to say about it. Now we have send data. Send data is just going to delegate to the send event method that's a part of the MMO peer, and we pass in the event data and the send parameters. So we have event.event data, and then we have event.send parameters. So all the information we need to know in order to send an event has already been packaged up for us in this event class, and we just delegate it to the send event method on the peer. Now we have a send system response. So send system response is going to need to invoke the send operation response method, which is a part of the peer, and it has an operation response parameter and a send parameters parameter. Now the operation response parameter is going to require I pass in an operation code and a dictionary of byte and object parameters. So what I can do here is, let's think, because we have these two overloads. The only difference between these two overloads is that I need to provide the result bytes on this overload, whereas I don't on this overload. Because remember, this overload's used for responses that don't have results, whereas this one's used with responses that do have results. So what we're going to need to do is, what we could do is, let me see, I could just copy and paste here. I mean, what we really need is we need an operation code and parameters. Now the operation code is going to be easy. I'm just going to add a new operation code enum member that says system sent response or something like that. And then we also need to fill in the parameters dictionary. So what I can do here is I'm just going to write this method out, and I'm going to write it against a method that doesn't exist yet, but hopefully that'll make sense here shortly. I'm going to say var parameters equals new dictionary, which is going to require I bring in system collections generic of byte and object. Then I'm going to call a method that doesn't exist yet. I'm going to say populate response parameters, passing in system invoke ID, response, and parameters. Actually, I want to pass in parameters as the first parameter of this method, and then system invoke ID followed by response. I think that order makes a little bit more sense. The responsibility of the populate response parameters method is simply to take the response in the system invoke ID and dump them into this dictionary. Then after I do that, I'm going to say send operation response, instantiating a new operation response. For the operation code, I cast a byte, and I pass in operation code dot send system response. Then as the second parameter to the constructor, I'm going to pass in our parameters dictionary. Finally, the last thing we need to do is send our send parameters, and I'm going to say event.reliable for that. And so this is really important because all of our operation responses all need to be reliable. They need to be reliable, again, because I absolutely need these events to be sent to the client, because the client could potentially hang the user interface until it receives a response. So they're always going to be reliable. Now you might be wondering if I'm going to ever address the send parameters a little bit more by allowing different channel IDs and different reliability and different abilities to do encrypted stuff in the future, and I do want to do that. But for now, we're just pretty much just sending everything on channel 0, everything as reliable, and we can build in the ability to overload that with the system in the future. Okay, so for the send system response overload that has results bytes, it's actually going to be pretty much the exact same method. So I'm going to say var parameters equals new dictionary of byte and object. I'm going to say populate response parameters, passing in parameters system invoke ID and response. Then I'm going to do one more thing here. I'm going to say parameters at byte operation parameter dot arguments, or no, how about just results byte, result bytes equals result bytes. Then I'm going to send operation response, instantiating a new operating response, operation response casting to byte, operation code dot send system response, comma parameters, sending it with event.reliable. Okay, so now we have to go ahead and implement our populate response parameters method. So I'm going to say private static void populate response parameters. It's going to take in a dictionary of byte and object parameters. It's going to take in a byte system invoke ID and an IRPC response. So what this method's going to do is I'm just going to say parameters at byte operation parameter. So we have method ID, system invoke ID. So we have system invoke ID already. I'll say system invoke ID equals system invoke ID. Then parameters cast a byte operation parameter. We need to pass in our response. And our response, if you recall, has our operation errors and our is valid. So what I'm going to do here is I'm going to use an enum member that doesn't exist yet, and I'm just going to say how about response is valid equals response.isValid, and then parameters at byte operation parameter. Then we're going to do operation errors equals response operation errors. And that should be it. So now what we need to do is we need to fill in these missing enum members here, our operation parameter and operation code. So I'm going to pop into operation code, and what we need here is we need our send system response member. So I'm going to add that in. Remember, this is operation code found in our infrastructure namespace. Now we need our operation parameters. So I'm going to open up that as well. And remember, operation parameters is also going to be located within our infrastructure namespace. I'm going to add result bytes. Response is valid. Ooh, I'm not going to call this operation errors. I'm going to call this response operation errors. So response operation errors. And that cleans up all our code. One thing though, I do have this arguments, and I actually really don't like the name here because these are argument bytes, not arguments. So since it's only used in one case, I'm going to go ahead and change that. So I'm going to call this argument bytes instead of arguments. Again, this is just a naming difference. It won't actually impact anything. Again, I'm in the client context class where I made that change here. But either way, that's really of no consequence. I just want to be more consistent with the with using the word bytes to refer to a parameter that's expected to be deserialized in addition to Photon's own deserialization. So by appending the word bytes to it, it implies that we need to do some more processing on that information until before we can do something useful with it. Either way, we now have our MMO peer pretty much where it needs to be. It's not a very complex class. And the system in general isn't that complex, but this class in particular is not going to be very complex because the majority of the processing is handled by our client context itself, not the MMO peer. But either way, now that we've done that, I think we're pretty much where we need to be with this entire assembly, for now. I mean, barring any bugs, which there's probably a decent amount of issues with the code as it's been written. Oh, and for one, I do need to find a way to actually add a system to the player context. I'm thinking of maybe actually having the player context, well, I might drop this down into a different assembly. And so I might take the player context and drop it down into the server master. But either way, so let's go ahead and talk about where we go from here. We have the basic framework for the systems pretty much implemented on the server side. Before we hop on over and actually implement the client side, I do want to go ahead and wire everything up. So like I said earlier, we're not going to be using the server region just yet. There's going to be a period of time where we're just going to be dealing with one server so that we can get things kind of moving forward, and then there'll be a period of refactoring the code out to work with a horizontal load balancing. So for now, all of our server code is going to go in the server master for things like movement and all that fun stuff. And so what we need to do is we need to have the server master use this new system, which really, it's going to be a two-step process. We need to go ahead and create a server context class in the server master, and we also need to create the implementation of our application. And that's it. So let's go ahead and do that. I'm going to hop on over to the server master project. I'm going to create a new class, and I'm going to call this master server context, and he's going to inherit from server context. Now server context is going to require that we have a constructor. It's also going to require that we have a configure. Remember, our configure method is used on our server context when it gets instantiated, when it needs to configure the IOC container. So you'll notice that we won't be able to implement this member yet, and the reason we won't is we don't have autofac added as a reference. So to fix that, we'll go over here to our references, manage NuGet packages, locate autofac, and install. Once we have that installed, we can now import the autofac namespace, and this code or this file stops erroring out. We're going to keep the master server context accepting an iSerializer so that we can change our serialization strategy at the topmost level of the application in the future. So we really need to worry about the configure method. Now the configure method is going to do quite a few different things. First of all, it does need to register our component maps and our system type registries. So we have our system type registry, and we're going to need to do a scan assembly of type of master server context. So if you recall, this scan assembly is going to scan for all of the classes that inherit or implement the iSystem base, and it's going to register the appropriate system for that. Now you need to do type of master server context.assembly. Again, this is how I will always retrieve assemblies, by the way. If you ever want to get a reference to an assembly, I will always do type of containing class dot assembly. And that prevents issues with dynamic assemblies dynamic assemblies and dynamic proxies changing like get type, that implementation to, you know what I mean. Like our executing assembly is not always going to be the assembly that we want. So I always anchor it into the assembly based off a class. So I don't rely on get type, and I don't rely on get executing assembly ever. Either way, so we'll scan the assembly for our system type registry. We also need to get our component maps working. Now, I don't need to worry about the actor component map because we haven't implemented the actor system yet. But I do need to worry about the player system component map. I need to auto map the assembly, and we'll do type of master server context.assembly, and we also need to retrieve if you recall, so we have this, or if I recall more appropriately, our components, so our components are actually not going to be registered from this current assembly. Only the scan assembly we need to do a registration for. The automap assembly on the player systems component map is going to be scanning the interfaces at the base project. So we haven't actually written any system interfaces yet. So what I want to do is I want to go ahead and create a login system interface, or system. Just the interfaces for a login system, so we have something to kind of work against as we start building up our client and see about things actually working. So inside of the base project, I'm going to create a new namespace, and I'm going to call this components, which there already is a components folder for some reason. Yeah, go away. Ignore me. Components, and then inside of components, I'm going to create another assembly called another namespace called systems, because we're going to have our actor components and our systems components. Inside of systems, I'm going to go ahead and create a login system. Now you'll notice I'm going to call the file login system, but it's going to have two interfaces inside of it. It's going to have iLogin system server and iLogin system client. And what we need to do is we need to annotate these two interfaces with an attribute so that we know to map them automatically with our automap method. Now we could map them manually if we wanted to, but that's kind of boring. So what I'm going to do is I'm going to open up infrastructure, the infrastructure namespace, and I'm going to create a new attribute. So I'm going to go ahead and create a new class, and it's going to be called automap component attribute. How about component interface attribute? I think that's a better name. It's going to inherit from attribute the system attribute class. So we'll have an import system, and we're going to give it an attribute usage. The attribute usage is going to have an at.class, and interface, so that the only thing we can apply this attribute to is an interface. Now the attribute itself is just going to be empty. It's nothing more than a way to mark particular interfaces as wanting to be automapped. Then I'm going to jump back into the login system file, and I'm going to add component interface and component interface. Then I'm going to go ahead and give both of these guys a method, just test methods. So I'm going to have a void basic test string message. I'm going to have an IRPC. I'm not going to worry about IRPC responses yet, because that will require another discussion about creating the concrete IRPC responses, and I don't want to do that until we have the client stuff figured out, because it'll make a lot more sense the way that I'm going to do it once we can see how it's going to plug into the code. And then on the iLogin system client, we'll have basic client test string message. So that'll basically be our two interfaces. Now that we've done that, we can jump all the way back into our master server context, and we're going to automap assembly. For the assembly we're passing in, I'm going to say type of iLogin system server dot assembly, and then the attribute selector is going to be type of component interface attribute. So our player systems are going to be mapped to anything that has the component interface attribute. Alright, so the next thing that we need to do is we do need to go ahead and write an implementation of the server-side interface for the iLogin system. And the reason we need to do that is because I want to show how we're going to actually add those into the container. So I'm going to go into the MMO Server Master project. I'm going to create a new folder, or new namespace, and I'm going to call this namespace Systems. Then I'm going to create a new class called Login System. Login System will inherit from player system base, passing in iLogin system server, iLogin system client, and he'll implement iLogin system server, and we'll go ahead and implement his one method, his basic test. And we're just going to leave this blank for now. Actually, I can just say throw new invalid operation exception message. Sure. So that will get something printed out to the logs. And so that's basically the login system. Now the cool thing about this is remember that the scan assembly on the system type registry will actually pick up this login system. So we don't need to annotate login system with any sort of attribute. We can just loop through our system type registry and find all of our concrete system types and then configure them with the container builder. Or we can do this manually as well. So what I'm saying is basically the autofact needs a way to be able to instantiate this class. So we need to tell it about this class. We could do this in one of two ways. I could say builder dot register type login system, import that up here, dot as self, and then instance per lifetime scope. So we could do that for every single system that we write, or we could say for each, I hate web templates so much, for each var system in system type registry dot. Now system type registry currently has no way to enumerate all available systems, so let's go ahead and actually fix that. I'm going to hop into the system type registry class, which is of course under our infrastructure namespace in our base project. And I'm going to create a new public property. I'm going to say public IEnumerable of registered system, and then I'm just going to call this registered systems. And it's going to have a getter, and I'm simply going to return concrete type to system.values. It actually doesn't matter which one of these dictionaries that I return from, because they're all pretty much kept in sync, but I just picked one random one. Either way, this will now return all of the systems that have been registered, which means it'll return all of the systems that we've scanned and picked up on. So jumping back into the master server context, we can now loop through all registered systems, and I can say builder.register type, passing in system.asself.instance per lifetime scope. So we can do this, well, hold on, system.concrete type is what I wanted right there. So we can do this, we can loop through all of the things that were scanned and picked up on, or we can just do them line by line. I'm just going to go ahead and leave it in this for each loop so that we don't have to worry about registering all of our other systems. Now what we can do is we can register our services, but we're not going to worry about that right now. Because I'm pretty sure, yeah, there's no need to do that. Yeah, there shouldn't be a need to do that yet. Okay, so here is our master server context. So now we can implement our application. Now a cool thing about this is I can actually delete this peer class. Well, this is where things get tricky. Well, yeah, I'll go ahead and delete the peer class for now. Keep things as simple as possible. So now we have our application that inherits from application base. I'm going to go ahead and create a constructor. And then I'm going to say private read-only master server context application. In the constructor, I'm going to say application equals new master server context, passing in a new instantiation of the simple serializer. For the create peer method, I'm simply going to return a new MMO peer, passing in the application and then the init request. And really, that's about it. Everything else gets handled through through the rest of the system. Now, the only thing that we have right now that's problematic is our systems are implemented in this namespace, which is in this project. And unfortunately, what I want to have happen is when a player gets created, I want him to attach a login system to himself. So we'll need a static reference to that from within the player context, but unfortunately the player context is in a different assembly, and he won't be able to have that. There could be a way, I suppose, to pass in a type. There's a couple ways to handle this. I could, inside of the server context, I could have an internal method or a protected internal method for configuring a player. Actually, I think I kind of like that. I think I kind of like that, leaving it. Yeah, because then it... See, I hate it when like designs aren't like perfect. Sometimes you have to break the rules a little bit. But I really like having the player context here, locked away inside of this assembly, because I think the player context is something that needs to be able to be understood by any of the servers, whether it be a region server, master server, whatever. We need some way to define a player context so that we can have player systems. But when they log into a particular server, we need some sort of initialization logic that will allow that server to perform specific operations. So what I'm going to do here is I'm going to make a small design fudge in order to handle what I want to have happen. What I'm going to do is in the server context, I'm going to say protected internal virtual void init player context. Or how about init player context? Now you could argue in one sense that initializing a player context is a responsibility that should only be on the player context class itself. You could make that argument. Or you could say that when a player connects to a server, the responsibility of initializing that player depends on the responsibilities of that server. So you could argue one way or the other that this is a good design. I think it's a meh design that allows us to get away with the architecture that I want. Anyway, protected internal. You probably haven't seen this ever. Protected internal is not used very often. In fact, a lot of people will say that it's a mistake to use it. But what's nice about it is it'll allow me to invoke this method from anywhere inside of the server assembly, or it'll allow me to reference this method in any class that inherits from server context. Again, you won't see it used very often, and I highly discourage its use in most cases, because again, what we're doing with this design is we're kind of taking part of the responsibility of the player context and putting it in the server. I'm not a big fan of that, and the fact I have to use this syntactical kludge to make it happen is probably an indication of a less than optimal design. On the other hand, I do really want the player context class to live in the server assembly, and I do really want the systems to live in the specific other assemblies. So, in order to facilitate that, we need to have some sort of way to initialize a player from within the master server context. Anyway, so how are we going to invoke this? Because, I just made a method, it's not like it's going to magically become invoked. Well, I'm going to come up here to the player context class, and after we send the player init event, I'm going to write application.init player context this. So, yeah. Now what I can do is I can come down here to my master server context class, and I can say protected override void init player context. And what are we going to do when we initialize a player context? We're going to say player context dot systems dot create login system. And that's that. So when a player connects, he gets a login system when he connects to a master server. Again, the only justification of me using this little accessibility kludge here is that different servers might want to do different things with different contexts, and this gives us the flexibility of doing that. So when a player connects to a master server, he gets a login system. When a player connects to a region server, he might get a different set of systems that are configured differently, and so on and so on. Either way, I think that pretty much wraps that all up. I mean, there's not much else to do here. I mean, this is really, that's the reason why this whole assembly exists, this Buzz MMO server, is so that the actual servers themselves do not have a lot of code in them. The only code the actual servers themselves should have are the actual game logic that is going to be mostly under the system's namespace. But I think that pretty much wraps up all I wanted to do, and we'll see you guys in the next video.